Hi, guys. Welcome to the Data Science Festival. We're excited to bring you our 10th festival. I'm Adam, a data scientist at Bupa, and I'll be your host this morning. Thank you all for coming and helping us to create such a thriving community. Please can you all switch your phones to silent. A schedule of talks and sessions is in your booklets, which you can find in your swag bags. If you have any questions, please find a data science team member who'll be wearing a staff t-shirt. There's also free water at the back of the room, so please help yourself. The Data Science Festival is a celebration of all things data. We aim to connect the tech community and foster the sharing of knowledge, inspiration, and ideas. Just a reminder that most talks will be recorded and uploaded to the Data Science Festival website and YouTube channel. If a room is full, please make your way to another one, and you can watch back any talks you missed. The event is free to attend and built by the community. Without the help of our sponsors, we couldn't make this event the success that it is. Thank you to Data Idols, BSI, The Trade Desk, OpenCradle, Snowflake, dunnhumby, Depop, Meta, NVIDIA, Key Insurance, Innovate UK, Bridge AI, and our bar sponsor, Sheridan's. Special thanks to Create Communities, who organised the logistics for today, and our AV sponsor Streambased, and finally CodeNode, who have given us such a great venue. Thank you again for attending the Data Science Festival Oktoberfest, and we hope you have a great day. Check out the back of your booklets for a free pint, and don't forget to enter the Data Science Festival competition also in your booklets. We're going to move on to our first talk of this morning. So that talk will be on moving data platforms to knowledge platforms. So our first speaker will be Simon Turner. Simon is a CTO at Foil. He's a visionary architect with a career shaped by technological evolution and innovation. With expertise in data, cloud technologies, and AI, he has led companies like Altius Consulting, Avanade, and ABN AMRO. Simon studied computer science and software engineering at Imperial College London and is known for blending humor with insights into technological disruption, turning complex technical jargon into compelling stories and future visions. If you all put your hands together for Simon.
Thanks, Adam. I'm going to use this up front, thanks. Not quite sure who wrote that bio, but it most definitely wasn't me. But I am Simon Turner. I'm not quite sure about the visionary, and I'm certainly not quite so sure about the humour bit at 9 a.m. on a Saturday morning. But I do thank you all for turning up at 9 a.m. on this very wet Saturday morning. And when I was first asked, I thought 19th of October. That rang a bell, firstly because I thought that's a Saturday, and secondly because I then realised that it was the day after my daughter's 18th birthday, which kind of made this a little bit awkward, so I had to get special permission to be here on the Saturday. But also, having a daughter that's just turned 18 made me feel really old. And I thought about that for a while and then realised that actually that's because I am really old. And so I started thinking a little bit about the whole topics of this talk and what I wanted to get across, and looking back at how you operate PowerPoint. There we go. And thinking about the topic of moving data platforms to knowledge platforms and what that looks like. And also looking back at the things that I've seen and the experiences that I've come across and trying to work out how some of these things have developed. Does anybody know what this is? So this is the first computer that I ever used. This is a thing called a Research Machines, an RML 380Z, and it's based on a Z80 processor. It's very old, 1974, I think it was. It ran at something like 2.7 megahertz. It had a ridiculously tiny amount of, I think, 64K of memory, which, of course, you can do nothing in these days at all. But for me, that was kind of the point, because everything that we built was built around the constraints that we had. So the programs that we wrote were small utility programs. They weren't vast kind of data crunching programs because you had nowhere to put them. Their thing had 5.25-inch floppy drives, which typically held about 128K. So if you couldn't get it into 128K, you couldn't do anything with it. So building big databases, that was kind of really, really tough. And it then, as technology developed, our ability to manage data moved with it a little bit. And the next set of companies that I worked for were very business focused and produced accounting software. And again, we still had 5 1/4-inch floppy disks and then 1/4-inch cartridges that we could send data and programs around on. And so the data estate grew slightly. Databases. Has anybody ever used a thing called CISAM, which is basically a flat file with an index file? And that was a really kind of basic sort of database. And it meant that we could store data from invoices and records about people in HR environments. And that's really where a lot of the ERP systems started. But again, we were really restricted about the volume of data and the way that we dealt with data because of the technology. And typically, what we ended up doing was using data to create reports. Now, I'm going to a bit of an apology. A lot of the images that I've created, I used DALL-E because I thought, it's data science, AI conference, I should probably be in on part of that. So some of them, the spelling, the text, it's really not very good at that. So just give me a little bit of latitude on the images, but it did an okay job in representing a slightly traditional, slightly historic view of how we used to use data to create reports, to retrospectively look at performance and understand how we had done in that space. Now, as we were able to start growing those data estates, we needed to look after them, and we started to build databases, and typically the world I came from, which was data platforms. And even with data platforms, they've been on a pretty interesting journey, and typically that journey has been driven by the advent and the development of technology. So we had databases, and the company that I worked for that did ERP systems moved on from flat files and CISAM and this new wonderful thing called SQL, and products from a company called Infomix, which is now part of IBM, Oracle, all sorts of other technologies like that. And we had databases, and these databases grew into data warehouses, these huge, great big amounts of data that were all controlled and managed by schemas, and they became the bastions of the IT department, and managing the schema and looking after additions to that was really, really kind of difficult. But again, the way we built schemas were really aimed at reporting. They were aimed to make things like SQL statements easier, to allowing us to gain insight from that data a little bit more natural in the way that we created those queries. Data grew, and we had the fascination with big data. And again, that was driven by the advent of things like the cloud, some of the big data processing technologies that we saw. And from there, we started to get a little bit more regimented about the way we managed big data, as we had data platforms, and we had different ways of layering the data and different ways of moving data through those systems. Databricks, we've got things like Data Factory, we've got different ways of managing the transformations in those processes. But typically, the data is still schematized in some form or another. We still look at it as an ERD. We still look at it in a way that is, in my books, kind of quite traditional. And it's being driven by the fact that we want to build reports and look at how we've retrospectively done things. Now, with the world changing in the pace that it's done, we want to make decisions. We want to be able to arm ourselves with enough information to make better decisions, kind of slightly more forward-looking in that space. But decisions are hard. We make a lot of decisions. Typically, every day, every adult makes somewhere in, and I don't know quite where this number's come from. This is one of my colleagues. 33,000 decisions we make every day. Some of those will be really, really small. Some of them will be in the black area on here. There'll be the volume things. There'll be, do I need another cup of tea? Shall I go and Costa coffee on the way to the conference on a Saturday morning? Right the way through to the really big ones over in the purple, the hard decisions that we have to make. Some of them sometimes can be completely life-changing. Those are hard. We need to be able to form and understand how we make those decisions better so that we can use the data to manage those. Now, the way that we make decisions is a very human, very personal thing. This is another one of ChatGPT's images, and what this is trying to show is the emotive, emotional, the very human way that we tend to make decisions. And we would, as a group of humans, we would call that gut feel. It's instinct, it's intuition. But that doesn't really translate into the data world. So what we're trying to understand is how, given the incredible amount of technical development we've seen and continue to see, and we will always see, it's one of those wonderful throwaway phrases. Everyone says, well, we're living in unprecedented times. Kind of argue that we're not really, because we've seen all sorts of industrial revolutions lots of times before. It's just another one of those, and we have to work out, again, as we did before, how we're going to cope with that. How do we live with that? How do we make best use out of that? And in our current industrial revolution, it's all around technology, it's data, it's information. And if you ask a lot of people, it's all about AI as well. How do we bring data to better bear to that particular type of problem? And around decision making, we need to understand how we move data from being very report oriented to being what we in FOIL class as knowledge. And for us, knowledge is this application of context to data. And what I want to try and do is just give you a little bit of insight into what we mean by context and how we apply that to data. And as you may have guessed from the title of the talk, the output of that is typically a knowledge platform, and what we mean by that, because there's multiple layers to that. The context for us is important because that's the bit that allows us to qualify what that difference between gut feel and informed decisions looks like. And we make all sorts of decisions on gut feel based on our experience, based on the knowledge that we have around us at that particular moment in time. It's not typically because we've got an ERD and groups of reports and things that we can kind of look at. Understanding, though, how we move that data from that ERD type world into this world of a knowledge platform is kind of interesting, though, because we need a different type of structure to it. I'm always very hesitant about using the word ontologies, but my colleague who was helping me with some of these slides said, don't worry, it's a technical audience. Can I just have a very, very quick show of hands? If I use the word ontologies, does everybody know roughly? Yeah, I've got a thumbs up at the back there. Great. So excellent. So, and as a developer, ontologies for me, because I've grown up with things like C++ and classes inheritance, ontologies kind of mean and something I'm very comfortable with. Being able to build an ontology that describes a business, though, is really, really tough because you start talking to business people about ontologies and it's not typically something that they're kind of used to. Classifying and breaking down different parts of their organization, different parts of their problem space into common entities, into things that for them sometimes don't really exist, but might be the beginning of a classification for something that does, is often very, very difficult. But what it does is it gives you an ability to provide context to the way that people look at data. And what are the things that we've been doing, and this is an example of one of the environments that we've been looking at building out for a charity, and you can see the boxes on there and it'll give you some idea as to the type of organization they're on there. The color coding is kind of important because the color coding provides data domains. And underneath this system, after we've built out an ontology for an organization in a particular domain space, and the other precursor to this is don't build an ontology for everything because it's like trying to build a canonical data model. It's almost an impossible task. But if you break them down, one of the great things with ontologies is they can be incremental. So you can start in a small space, you can then build them up. Now, this one, I personally think is technically incorrect, because there's all sorts of things that this structure precludes. So, for example, it suggests that a volunteer can't be a donor without effectively changing type. And there's things like that the systems that we've been using to help build these are nowhere near as good as humans. And actually sitting down and understanding the problem is a really important part of the process. But what the tool does is it allows us to turn this into a lump of code that sits behind this. There's a JSON definition that sits behind this, and it allows us to create this in a form that things like ChatGPT will understand. And that language, that document that this generates, becomes the context for how we start talking to AI. Now, I'm going to come back to that, because the other thing that this does at the leaf node level is it gives us the relationship between entities. And those entities become instances of things, typically within our problem space, and those in turn allow us to define knowledge graphs. Now, you can think of, I talk about upside down ice cream cone, which is, again, coming back to my daughter, who's dropped many ice cream cones over the years. But if you think about it as an upside down pyramid, the ontology is the thing that defines the inherent structure that sits above the entities at the bottom. And by the time you get to actually talking about real things in the real world, you're at this leaf node level of your ontology. And at that point, you also, because of the way the ontologies work, in this diagram, curvy lines are relationships. Because of the relationships, you've got this ability to create a knowledge graph. Now, knowledge graphs, this is an example of a knowledge graph that we did for an airline, and there's a reason I picked on this, as I'll show you on the next slide. This is how we were looking at a very small part of their domain. There's a thing within the airline industry called EU 261 compensation. And that basically says that if you get delayed for 3 hours, they'll give you vouchers for Starbucks. And if they delay you for more than 4 hours, you basically get your money back. But it's cumulative. So it means that the airline that caused the delay, if you've got a multi-leg journey, the airline that caused the delay in the first instance has to pick up the tab for all of the subsequent delays. So it can be very, very expensive. Understanding where an airline has headroom in terms of which flights, if you have to, which flights should you cancel versus which ones should you absolutely protect. It's a value decision. If you cancel flights, I mean, it can cost them £250,000 just to start rescheduling people. So it's really, really expensive. How do you look at the information in a way that allows you to make these decisions based on facts and data as opposed to gut feel? When we first started doing this and we were talking to the dispatchers at Heathrow, they said, well, we've been doing this for 27 years. We know on a Tuesday you can cancel these flights and it's all going to be absolutely fine. At the end of the project, when we started showing them the output of this, it completely changed their opinion, because there were things that they didn't see, they couldn't see, because it was that multiplicity of facts in there with the data that meant that they were making good decisions but not the best decisions. What we did for them, though, was try to understand what the knowledge graph would look like for this data, because, and you'll see on the next slide, we displayed the output of this to them as a knowledge graph. The trick is understanding what the nodes look like. And one of the biggest things that we had the biggest problem with was this thing called booking, because obviously for an airline, booking's a revenue, so therefore it's the most important thing in the world. And they couldn't get their heads around why this wasn't a node within the knowledge graph. And when you break it down, what you're actually doing is you're talking about, for a booking, it's a relationship that ties me as a passenger to a flight number. Now, it's only to a flight number. It's not to an aeroplane, because they can change the aeroplanes. The flight number doesn't change. So there's lots of different layers that you need to think about how you create what ultimately, and I really don't like using this word, what ultimately is the schema for the knowledge graph. How do you create that structure for it? If you can do that and you can simplify it, you start to get an incredible efficiency in the way that you represent data in this space. And it also means that the questions and the queries that you make over this data becomes a lot more efficient. Now, the airline industry, there's a kind of a bit of a an oddity that made these types of systems as a knowledge platform work reasonably well, which is that they work on a fortnightly cycle. So typically, as Google Maps would tell us, typically you can deal with a 14-day window of data, because one of the things that knowledge graphs aren't best suited for is time. Dealing with time, dealing with schedules within a knowledge graph is a bit of a challenging one. So with the airline industry, this 14-day window meant that we could effectively time box the amount of data that we structured in this way. So that made it a lot more manageable in that space. But it also means that when you look at a knowledge graph, it shouldn't typically be the only thing within your data estate. I've got an architecture diagram in a moment, which is a bit of an eye test as well, but you'll see things like the data lakes, they're still very much there as well as the knowledge graphs that sit on top of it. What you could see on the right-hand side is effectively the environment that we ended up building for them. And yeah, there's a slightly strange story in that we had a problem with one of the font files that meant the airplanes came out as pigs in one of our demos. And of course, you don't discover that until you're about to do the demo. And we had a page full of pigs, which they thought was quite funny, which was lucky. But what this allows us to see is how and where people are related to flight numbers, and also the flight status of those flight numbers. And then also the way that the airplanes move on these routes as well. And that allowed us to, with some of the traversal languages, obviously we used open source, so everything had strange names like Tinkerpop and Gremlin. But Gremlin was the first language that we used in this environment. And it's what's called a traversal language, which allows you to describe queries in the way that you move through the graph. So from one node to the next node to the next, depending on certain values and conditions of relationships. And the other really interesting thing with the knowledge graphs is that the relationships can also hold values. So instead of just having an ERD with foreign key relationships, the relationships within the knowledge graph can hold anything you like, all sorts of different bits of value. And that's really where we stored things like the booking values and the references to things like revenue, because they are queryable entities that you can use to derive both reports and decisions out of this space as well. Now, the thing with the knowledge graph, as I said, you need obviously an architecture, but it's not, because of the way they work, they're not best suited to storing absolutely everything. So you still need an environment that allows you to effectively work with traditional data lakes, data platforms, where you store the archive, the history. We have different types of talks that we give around some of this. When we talk about this environment, we talk about the data platform as effectively being the digital memory, and the knowledge graph being a little bit more like the digital nervous system. And then the last part of that is the digital brain, which is just the AI environment. And the AI environments here are really, really important and also really useful. And I'll touch on those in 2 seconds. Just very quickly, obviously we've got the data lake, the main storage area for the archive of the data, but it's the layers on top, and typically the one that sits up here, which allows us to manage the ontologies that we were talking about earlier, and turn those into knowledge graphs. There's all sorts of products out there. We're quite Microsoft-oriented in a lot of what we do, so we use Cosmos DB as kind of a first instance until it ends up costing us way too much and we have to use slightly cheaper products. Is there anybody from Microsoft here? Am I allowed to say that? But it's a really good product, but it does have cost constraints, and you need to manage the information in there well. They talk after me in one of the rooms over there is from the team for Neo4j, and they're talking about knowledge graphs as well. And again, Neo4j is a very good product for storing graph-based data in that space. And there's other extensions to things like Postgres. But it allows you to represent the data in a very, very different way from what we are traditionally used to, which is the ERD for things like reporting. And knowledge graphs allow us to store the data in a much more natural, much more decision and query-centric way. But what they also do is they give us this ability to manage and store context. So we talked a little bit about the ontologies. The other aspect of this is how we take this into the memory environments of AI. Now, obviously, for the last 2 years, no one's really wanted to talk about anything else except AI and ChatGPT. 22nd of November 2022, I think it was, when ChatGPT sort of first made its way out into the public domain. Certainly, from then on, nobody wanted to talk about anything else. And it's a great tool. It's not particularly brilliant at drawing pictures, but it's still better than I am. But what it is a very, very good generic tool. It's ingested goodness knows what percentage of the internet. So it has lots of information at its fingertips. Some of it's right, some of it's not quite so right. And it will use that information to form answers when we ask it questions. But it won't know about my business. And it will only know to the point of its data cutoff at that level as well. If we have a mechanism of providing information from our business with context, it can be a lot more informative in the way that it answers questions in that space. And so one of the things that we've been doing is we've been using ChatGPT and some of the other models to answer these questions by giving it context. So we'll give it the digital representation of the ontology that I was talking about, this JSON schema, which effectively describes the domain, the problem space. We will give it the relevant parts of the knowledge graph, all in codified form, and then ask it questions. And it's surprisingly good at answering questions when you give it context. And what we're currently working on is a structure around agents and assistants. Everybody gets has everybody heard the phrase agentic models and agentic processes? I sometimes get a little bit frustrated with our industry and how we're constantly inventing new phrases and coming up with new terms. But the concept of agents and assistants is quite an interesting one, because it's not particularly complicated. You can create an AI assistant in OpenAI's playground environment really, really quickly, and you can get it to do a relatively defined task based on the particular prompt that you give it. But this concept of having groups of assistants working as a team, doing very defined parts of a particular problem space is a really interesting one, because you need those smaller assistants to understand the context of the question that you're answering. There's a couple of lines missing on this diagram, and one of those is a feedback loop, because what we've also realized is we can get it to be self-critical at this point as well. And because the assistants are created dynamically based on sets of text that's in a YAML file, you can get it to effectively critique that YAML and improve it based on human interaction and human feedback, based on the results that come out of the assistants as well. But again, it still needs structure. It needs context in that space. And that's really where, for us, the knowledge graph and being able to look at data in a different way, in something that's more human-centric, not just as ERDs and schemas in a relational database, for us is really, really important. Now, I'm going to leave a little bit of time at the end for questions, but I just wanted to check to see if that is kind of making sense. Some nodding heads and things. Excellent, thank you. Because one of the things that we're also focusing on in this area is what's the value for this? Where does this go? Because this might be slightly controversial, and I really like ChatGPT, but it's not all about shiny new chatbots. There is a massive, humongous amount of money that's been invested in these AI platforms, and we need to understand how and where we drive return on investment for that. And For us, that is all around the area of business automation. So Gartner, 3 or 4 years ago, coined this phrase of the autonomic business. Now, we all have autonomic nervous systems. Breathing is an autonomic function. If we try and hold our breath, eventually your autonomic nervous system kicks in and says, pay no attention to the brain, please start breathing, because it has one job, and that's to maintain your blood oxygen saturation, and that's the only thing it cares about. And it will do anything it can to make sure that it hits those goals. And that's what an autonomic process does within an organization. If you can give it the boundaries and the guidelines that you want it to work within, it will look after your stock levels, it will look after your maintenance optimization, it will look after cash flow. It's not one process that does all of those, it would be a collection of different ones that do specific functions. But if you've got enough information and enough context about your business, building those models becomes much more obtainable, and you can then put those collections of models together to do those higher order functions. And that's really where we see the next level of evolution from both data in form of things like knowledge graphs and AI in the forms of assistants and some of the models to be able to create this level of automation for organizations. The models, we just about at the point proving that we can build the models almost automatically based on the ontologies and the flow of information through the knowledge graph, and then putting those into an environment that allows for execution means that we can automate some of these functions. And as it says here, if we can automate, and I'm not for 1 second suggesting that some of those higher order functions are really easy, and monitoring cash flow and those types of processes within an organization aren't necessarily easy, but they are definable. They are things that we can create levels of automation for. And if we can do that, it allows us to focus on the things that are really hard, the things that are human-centric, that AI can't do for us, because there are lots of things that AI can't do. It's not going to destroy the human race, it can't do original thought, and it needs humans to be that human-centric part of the puzzle. But we've got to take away some of the things that currently occupy most of our time. And that's really where the return on investment comes from within the space of AI. I'm going to stop now, because I think Adam's about to show me a card that says 5 minutes. Thank you for listening. Does anybody have any questions? Sorry, 2 seconds. Adam's just going to bring a microphone over to you. Okay.
Simon, I saw on your one of your slides that you've actually allocated the entire layer, which is a Microsoft layer. The risk of depending on one vendor, especially after CrowdStrike, do you just want to educate us onto
in this one here,
semantic kernel by Microsoft?
So we look, and that is a great question, and really being able to understand where your dependencies look like. And CrowdStrike's a great example. And I would love if we had more time to talk about the whole issue of trust in this space as well, and what does trust look like in that whole area, because that ultimately is where the sort of the CrowdStrike problem came from in that environment. The way we use semantic kernel, partly it's open source, so we feel relatively comfortable in that space, because I think your question is super valid. Making sure that we are both agile and AI resilient in this world is massively important, because things change very quickly and very dramatically. Putting all of your eggs in one basket, it's not a good thing to do. We use that layer because it provides us with flexibility to use different models in different ways, but also because it's open source. So we can take different pieces out of that if we need to. So I completely get your point. We don't see it as a dependency in that area, though, or a risk that we need to worry about in that space, because it's open source and because it gives us flexibility in other areas. Does that make sense? Because I totally get your point, but it's one of those areas where we get value from it at the moment. But it is, as I say, it is open source. But thank you.
Excellent talk. Thank you very much. When you're talking about codifying the kind of existing ontology of the way that the client interprets their sector to be,
Yeah.
I wonder if you take it to the level of actual practice. So to say this is actually the way that the business operates, not only the way that the pieces tie together, but the fact that this person doesn't talk to that one, that this department has a backlog of about 3 weeks and effectively doesn't deal with things because, you know, I've realized that in the things that I do, that's where everything falls down. The theoretical knowledge of the ontology is actually not what is happening.
Yeah. Yeah, that's such a great question. And that is exactly what we're finding. And it's a fascinating process to be part of with organizations, because you'll get one group of people that have this view that they articulate about how their particular domain works, and they'll draw it up on the board, and they go, "There's," and then you'll get another team of people that come in and go, "Yeah, but we never does it that way." And we've done it in different ways with different organizations. We did it with a publishing company, and we very purposefully chose different people from different parts of the business for a whole day to draw out how their... The other thing that I'm very careful with ontologies is to separate the ontological description of things from processes, because for us processes are really bad things and terribly confusing and really only there to transform entities from one state to another, but that's another rant that I have. But we tried to get them to think very separately from the structure of the business, from the processes that they employed. And we spent about 2 days with umpteen whiteboards drawing out their business in this way. And at the end of it, there was this kind of deathly silence. And they said, actually, it kind of makes sense. We've never seen our business drawn that way. And it's a really challenging part of the process to get people to understand what things are today versus what they think things either should be or can be in the future. And that's part of the things that we get involved with, is how do you move organizations from, and this typically for me is quite an uncomfortable area, because it's not technology, it's people, it's emotions, it's a very challenging part of the process. And luckily I've got colleagues that deal with all of that and just let me get on with the easy stuff, which is the tech. But it's very difficult to get organizations to be disciplined about what things look like today versus what they think things should look like. The ontologies we found have really helped organizations to see that journey, because you can sort of draw them out and you can show them what a transformation looks like. Transformation then becomes something that you can actually document, as opposed to something grey that's in other groups of consultants' heads and things. Great question, though, because that is, yeah, it's such a challenge, that one. Does anybody have any other questions?
I guess a more general question, drawing on your experience in the industry, and that's a really interesting talk, but we always seem to be on the cusp of these automations for the last 30 odd years, and it's different now, we always say.
Yeah.
But then I guess the emotions and everything kicks into actual decision making. Where do you think we are, and are we just another sort of hype cycle?
Oh, so I desperately hope that we're not in another hype cycle, because does anybody know when the term AI was first used? Yeah, it was 1957, and it was a conference in Dartford in the States somewhere. So the term AI has been around for a long time, and it's only really in the last 2 years that this big level of excitement's come about. But in that time, from 1957 to where we are now, we've had 2 winters of discontent with AI, where that level of investment really outstripped anything that was being delivered, and most organizations just said, right, that's it. AI is never going to deliver anything, so we're not going to pump any more money into it. And in this latest round, for me, it was a real concern, because vast amounts of investment, and without being able to really see measurable return on investment, it is possible that we'd hit another winter of discontent. And you've only got to look at the reports recently from Goldman Sachs and some of the other people that are out there, that they are nervous that that might happen at the minute. Now, I am the eternal optimist, so this is not a good question for me to answer, because I'm always going to say, yeah, no, we're going to be fine. But I do genuinely think that we will. I think that there are a number of different factors now. The level of awareness that we have within the rest of the population, in consumerism in particular now around AI, is very, very different from what it was in the first instance. So I do think that there is a lot of factors like that that will mean that this will be driven to success. The challenge is where we see that return, because whilst some of the things that you can do in the chatbot world, and I'm not an iPhone user, I apologize for that, but I know Apple Intelligence is arriving in sometime in December. These personal assistants and the things that you can get them to do now are really, really brilliant. And as a human-computer interface, they're fantastic. But we've got to be able to deliver value. We have to not just be able to talk to our technology in an amusing way. We've got to be able to get it to deliver value. And that's the thing I think that we're starting to see now in the way that we manage information and data. Instead of it just being about relational databases, it's about a much more human-centric way of managing data. And that's the thing I think that's going to push through to sort of value and, that sounds, I was going to say success, but I didn't want to sound too over-optimistic. But there's a lot else going on now that we haven't had previously. So I'm massively optimistic, I think. How about you? I mean, what do you think?
Probably less optimistic. I wasn't just thinking about AI, I was just thinking about the number of times I was promised an automated system built to deliver.
But we had previously, it was RPA, the whole sort of robotic process automation, which was the next round of business automation and things. And I think that what we're starting to see now is it's moving out of the realms of the IT department, and it's becoming a much more board-level discussion now. If you talked about RPA to the C-suite, they typically would just nod and sort of think it was part of the MI and the BI department. There's a real, whether it's well-placed or not, there's a real hunger to try and do stuff at that level. Now, I've had lots of conversations with organizations where the conversation's gone, yeah, but Simon, I just need to show my CEO that we're doing something with ChatGPT, at which point I hang my head in my hands and try and steer the conversation in a different direction. But that level of recognition of importance at this point, I think, is the thing that's going to change that. I genuinely think that automation is massively important for this, because I think that's the area where it allows. Last year I was at the Microsoft Build conference in Seattle, which was great. And Satya Nadella did his keynote presentation. 55 seconds into his keynote presentation, he had a video of a doctor saying that what this really gave her was time back with her patients. And you could have stopped the conference at that point for me, because that was the essence of what this was about. It was about giving us as humans more time, not to do away with jobs, not to change the landscape of the way we employ people, but to allow us to be more human-centric and to give us time. And that's what the automation will do. And it's the organizations that recognize that this isn't a way of cutting heads, but this is a way of creating more innovation. They're the people that will be really successful. Thank you very much for listening and indulging me on this great Saturday morning. Thanks, Adam.